A very natural step in any regression pipeline is to begin with simple linear regression. Recall that simple linear regression refers to the case where we only have one independent variable. The good thing about starting with simple linear regression is that it provides us with a very simple and interpretable model that we can use as a baseline before we move on to more complicated models. So what do we need to do before we tackle simple linear regression? Well, we need to choose what our dependent and independent variable are going to be. One way to do this is to visualize the scatter plots between each of our variables and then choose as our independent variable the one that shows the strongest linear relationship with our dependent variable. So let's start by importing our plotting library. We're going to use Seaborn for this. So I'm going to import Seaborn under the usual alias. And then this is not always necessary, matplotlib inline, but I like to keep it here just in case to show the plots in the Jupyter notebook. So let's begin by creating a pair plot to visualize all of the relationships between our variables. We can do this with Seaborn's pair plot function. We can just directly pass in our data frame. As you can see, pair plots can be a little bit slow. Here we have only 4 numerical variables or 5 numerical variables, and it's already taking quite a bit of time. And there's a lot of information to digest. I'm actually going to have to zoom out just a little bit. But the information they provide is incredibly rich. So here on the columns, on the rows and on the columns, we have all of our numerical variables. So average session length, the time on the app, time on the website, length of membership, and the yearly amount spent. And we have the same as the rows. In the diagonal, where we have each variable, it makes no sense to create a scatter plot of a variable with itself, as it would just be a straight line that contains no information. Seaborn provides us with a histogram of the distribution of that variable, so we can quickly use this to see all of these variables seem normally distributed, and that's what we see along the diagonal. Off diagonal, we can see the scatter plot of time on app, in this case, time on app versus average session length, time on website versus average session length, and so on. Let's begin by choosing what our dependent variable is going to be. In this case, it seems very clear-cut. It's going to be the yearly amount spent. So let's focus on this very last row where we have the yearly amount spent on the y-axis and all of the potential candidates for independent variable here on the x-axis. And our goal for simple linear regression is to choose the variable that we believe has the strongest, more clear linear relationship with the yearly amount spent. And in this case, it seems very natural that the length of membership is the one that exhibits the strongest relationship with yearly amount spent. Now, before we move on, I just want to show you a couple tricks. This pair plot function by Seaborn is incredibly powerful and it offers a lot of customization. So I just want to show you some things that I like to do. First thing we can do is, since the pair plots are symmetric, because the time on app versus length of membership and length of membership versus time on app, these are the very same pair plot, only inverted. So we don't really need both off diagonals. So the first thing we can do is just use this corner true to turn that off. So I'm going to start pair plot, the F, and I'm going to set corner equals true. This makes the plotting a little bit faster just because it doesn't have to plot all of these unnecessary or redundant pair plots. This is really nice. Another thing we can do is we can change these histograms into density plots, which are linear sort of estimations of the density. We do this by setting the diagonal kind. So I'm going to set diagonal kind equal to a kernel density estimation. So this is just another way of visualizing the distribution of our variables instead of using a histogram. It's entirely up to you which one to use. And another thing we can do is we can turn these scatter plots into linear regression themselves. So this is a little trick and it takes a little bit to run. So don't use this if you have a lot of variables. But if we set the kind of the plot to regression, it's gonna calculate, Seaborn is gonna calculate simple linear regressions for each of these combinations and show you the regression line. So as you see, it takes a little bit longer to run, but now we see each of these scatter plots now has the tentative regression line along with some confidence intervals. So this only stresses the fact that we made a right choice by choosing length of membership as the most significant independent variable, because we see there's the confidence level for the regression. The confidence intervals are very tight. And finally, just cherry on top, if you find these scattered plots a little bit crowded, we can change the marker. So I'm just going to change it to something a little bit less invasive. I'm going to set it to, say, a plus sign. And here it is. I've gotten the pair plot into a shape, into a form now that's very informative and highly readable.